In question 5, we've got the quadratic 2x squared plus 8x minus 10, and we're asked to express it in the form a times x plus b all squared plus c. Now this one's a little different to the other examples we've looked at so far because of this constant out the front. So we can see that there's a common factor of 2, particularly in the first two terms. We could also include this 10, but it's usually easier because you can see you've got a constant on the end and a constant on the end here, just to factorise the first two terms. So we can take 2x squared plus 4x and then leave our minus 10 as it was. It's not fully factorised, but it's going to help us do a little bit more with our completed square. So now just exploring this next bit, we know we've got x plus 2 all squared. So if I was to expand that out, I'd get my x squared and my 4x, but I'd get this accidental positive 4 that's also multiplied by 2. So when I expand all of this, I will get the 2x squared plus 8x, but on the end I'm going to get positive 8 and I need negative 10. So I'll need to subtract 18 from that. And so now we've got it in the form that's required. The a value is 2 and the c value is negative 18. So that's the first part. Now it says state the least value of y in part 2. State the least value of y and the corresponding value of x. So when I look at this graph, I know that it's been moved to the left 2. I know that it's quite a lot steeper, if you like, than a regular parabola, and I know it's been translated down 18. So it's looking like this. And I know that this vertex, which I can read from the equation, that the vertex is at negative 2, negative 18. And I can get that from these two values within the equation. So that means that the least value of y, minimum value of y, is negative 18 when x equals negative 2. Now we just have to do part 3, which asks us to find the set of values of x for which y is greater than or equal to 14. So if we take that equation that we've been working with, we can use it in any form that we've had so far, but let's just go back to the original. And this is supposed to be greater than or equal to 14. So we want to make this all equal to 0 and then factorise, or we'll use the quadratic formula if we have to. So 2x squared plus 8x minus 24 is greater than or equal to 0. Could take out a common factor of 2, and now I'm left with something that I should be able to factorise a little bit more simply. So if we look at those two, we'll have what? Positive 6 and negative 2. And so when we solve it, we'll end up with x is negative 6 and x is positive 2. Now these are my endpoints because I'm solving an inequality here. These inequality signs are telling me this isn't the exact solution. We are looking for a place or a series of x values which will satisfy the equation. So I know that they're going to cut through at negative 6 and positive 2. That's going to look like this. And I'm looking for where x is greater than or equal to 0 when I form my equation. So these two branches on the quadratic, which means that I want x to be greater than or equal to 2, and I'm also going to find correct x values or correct solutions if the x values are smaller than negative 6. So there are my domains that will make this work. Right, so we're checking this by looking at the graph and seeing which parts will create a greater than 0. Right, question 6 asks us to find the points of intersection between a curve and a line. So once again, easiest if we can get one of these in the form of just a single letter. So y equals 12 over x as an example. So now we want to substitute that y into this equation. So we'll end up with 12 over x plus 2x equals 11. And because we don't like having this variable in the denominator, we can multiply everything through by x, and then we'll make it all set equal to 0, and rewrite it in a form that we're more familiar with. And now at this point we can either try to factorize it or we can go to the quadratic formula. I think I'd probably go to the quadratic formula at this stage. You can, because we know what the answers are now, we can have a look and see if there is something, but I'd just go straight to the quadratic formula. So negative of b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2a, so all over 4 in this case. So remember that what this is finding us our quadratic formula are values for x. So if we look at this now, we'll have 11 plus or minus 121 minus the 86 and 96 will end up with 25 plus or minus the square root of 25 all over 4. So we'll have two x answers coming out of this. So one is 11 plus 5, which is 16 over 4 or 4, and the other is if we do 11 minus 5, so we end up with 6 over 4 or 3 over 2. Now those are our x values. We know that we now need to substitute when x equals 4 into one of our y equations. So right at the top we had y equals 12 over x, or we could have y equals 11 minus 2x. Both would be fine. So we'll substitute our y values in, our x values in rather, so we're just going to use 12 over 4, so y equals 3. And if we use the other x value, when x equals 3 over 2, then y equals 12 over 3 over 2. Now we don't like that, that's messy, so obviously you'd probably go straight to your calculator, but let's look at how we could work that out. When we're dividing by a fraction, it's the same as multiplying by the reciprocal. So now we've got 24 divided by 3, or 8. So we've got 2 points of intersection. They are 4, 3, and 3 over 2, or 1.58. And there's our points.